The woman kneeling in the courtyard cannot see what she is doing to her child. She dips a slender bone applicator into a small alabaster pot, no taller than her palm, and draws a smooth black line along her daughter's lower eyelid. The girl is maybe 4. She blinks. Her mother steadies her chin with one hand and extends the line toward the temple, that distinctive Egyptian sweep you have seen on coffin lids and tomb paintings for as long as you can remember. The coal is dark gray, almost black, ground to a fine powder and mixed with animal fat until it holds. It goes on cool. It smells faintly of tallow. And it is poison, not raw or carelessly smeared on skin. Not ignorance. In 1999, a team of chemists at the Laboratoire de Recherche des Musées de France analyzed cosmetic samples from the Louvre's Egyptian collection and found 4 distinct lead-based compounds in that little pot. 2 of them, laurionite and phosgenite, do not exist anywhere in nature. They had to be manufactured. The Egyptians were synthesizing lead chloride compounds through a deliberate wet chemistry process, grinding, heating, mixing, steps that required chemical knowledge we would not expect from a civilization that predates Aristotle by millennia. They were not primitive. They were advanced chemists. And the compound they manufactured was a neurotoxin that entered the bloodstream through the tear ducts and the thin skin around the eyes, accumulating in bone and soft tissue over a lifetime. Abdominal pain, cognitive decline, anemia, kidney damage, infertility. None of it traceable, in their world, to the beautiful dark lines they painted on every morning. Here is where it gets complicated. A 2010 study demonstrated that those same lead chloride compounds, at very low concentrations, stimulate nitric oxide production in skin cells. Nitric oxide is a genuine antimicrobial agent. The Nile floodplain was rife with bacterial eye infections, and coal may have actually reduced the incidence of acute conjunctivitis. The Egyptians may have observed, across generations, that people who wore coal got fewer eye infections. They may have been making a rational pharmaceutical trade-off, protection against a visible threat at the cost of an invisible one no civilization on Earth would understand for another 3,000 years. They understood the benefit. They could not have known the cost, and they applied it to their children. The Ebers. Papyrus, dating to roughly 1550 BCE, includes cosmetic preparations for infants. Lead compounds around the eyes of a child whose developing brain is most vulnerable to exactly this kind of slow, cumulative damage. A mother's love, expressed in the language of her culture, delivering a toxin she had no way to detect, no reason to suspect, no framework to understand. This is what forensic science has done to our picture of ancient Egypt. Not demolished it, sharpened it. Since the 1970s, when Rosalie David initiated the Manchester Egyptian Mummy Research Project, CT scanning, mass spectrometry, electron microscopy, and ancient DNA analysis have turned mummies into medical patients whose case histories can be read thousands of years after their last breath. What those case histories reveal is a civilization of extraordinary intelligence and sophistication that was being quietly consumed by its own daily routines. Not because they were foolish, because they were human, operating at the edge of what observation could teach them in a world where the most dangerous things were the ones you could not see. Consider bread. You have eaten bread your entire life without thinking about how the flour was made. In ancient Egypt, bread was made from emmer wheat ground on saddle querns, one stone pushed back and forth across another by a woman kneeling on a packed earth floor, hours every day, her forearms aching, fine dust rising into the still air of a mud brick house. Delwyn Samuel, an archaeobotanist who put ancient Egyptian bread under a scanning electron microscope, found quartz sand particles and stone fragments from the grinding surface embedded throughout the bread matrix. Every loaf contained grit, not because the baker was careless, because you cannot grind stone against stone without grinding the stone into the flour. The technology made it inevitable. Now look at the teeth. In 1972, F. Filch Leake published a systematic study of dental attrition in Egyptian mummies and found something that modern dentists recognize instantly. The teeth were not decayed. They were abraded, worn flat in a horizontal plane, ground down to the gum line by decades of chewing sand and stone with every meal. Pulp chambers exposed, roots visible, and at the base of those ruined teeth, dark shadows on the X-rays, periapical abscesses where oral bacteria had entered the bloodstream through pathways carved by bread. In a world without antibiotics, a dental abscess could kill you. And it did. Roger Forshaw's 2009 study in the British Dental Journal documented endemic dental abscesses, periapical lesions, and severe periodontal disease across Egyptian populations. This was not a disease of poverty. The X-ray Atlas of the Royal Mummies, published in 1980, showed that pharaohs suffered the same destruction. Ramesses II, who likely lived into his late 80s or early 90s, had teeth worn almost beyond recognition. He had access to the finest food in the ancient world. But the finest food was ground on the same stone querns as a laborer's ration. Wealth bought more bread. It did not buy safer bread. Every mouth, every day, 3,000 years. If you have ever bitten down on a piece of grit in poorly washed salad and felt that jolt, that wrongness of stone against enamel, multiply that by every meal of a lifetime. That is what Egypt ate. And what Egypt drank was no better. Forget what you picture when you hear the word beer. Egyptian beer was not golden, not clear, not carbonated. It was thick, opaque, yellowish-brown, brewed by crumbling partially baked bread loaves into water and letting the mixture ferment in open clay vessels. Sediment floated. Fragments of grain drifted in a porridge-like slurry that was drunk through strainers because it was too thick to sip. It was not recreation. It was the national drink, consumed by men, women, and children at every social level, issued as daily wages to the workers who built the tombs in the Valley of the Kings. The water used to make it came straight from the Nile, unboiled. The vessels sat open under the sun. And the Nile, the river that made Egyptian civilization possible, was also the largest parasite reservoir in the ancient Mediterranean. In 1910, a man named Mark Armon Ruffer did something no one had done before. He cut into the kidney tissue of a mummy from the 20th dynasty, roughly 1100 BCE, and found calcified eggs of Schistosoma hematobium embedded in the tissue. Bilharzia, a parasitic flatworm whose larval stage develops inside freshwater snails, then burrows through human skin on contact with contaminated water. It migrates to the blood vessels around the bladder and liver, lays eggs, and triggers an immune response that, over decades, destroys organs from the inside. Ruffer had just proven that a disease still infecting millions of Egyptians today was already endemic more than 3,000 years ago. The same river, the same parasite, the same slow destruction of livers and kidneys across an entire population that had no concept of what was happening to them. And it was not only schistosomiasis. Rosalie David's parasitological studies at Manchester identified tapeworm, roundworm, and trichinella in mummy tissues. Hookworm eggs have been found in remains, the kind of soil-transmitted parasite that enters through the bare soles of feet, walking in warm, moist Nile mud. Every step a barefoot farmer took in his own flooded field was an invitation. Chronic hookworm infection causes iron deficiency anemia, fatigue, impaired growth in children. Not dramatic, not visible. Just a quiet, permanent diminishment that nobody could trace to the soil under their feet. The Nile gave Egypt everything, and the Nile took a percentage of everything it gave. If you have ever stood in a cathedral and watched incense smoke climb through a shaft of light, you have felt, for a moment, what an Egyptian priest lived inside for decades. But the cathedral has vaulted ceilings, rose windows, open doors. An Egyptian temple was the opposite. Richard Wilkinson's architectural studies describe inner sanctuaries designed to be as dark and enclosed as possible. Thick stone walls, no windows, ceilings low relative to the dense forest of painted columns, light entering only through narrow clerestory slits or not at all. This was theology made physical. The god dwelt in darkness. The priest entered that darkness daily, carrying a bronze censer loaded with frankincense, myrrh, kyphi, resins that burned into clouds of aromatic smoke with nowhere to go. The smoke hung in layers. It filled the space between the painted columns, drifted across ceilings covered in golden stars, settled into the lungs of the men who served there year after year. Andreas Nerlich and colleagues found anthracosis, carbon deposits in lung tissue, in Egyptian mummies at rates comparable to modern populations exposed to indoor biomass burning. The priests were not the only ones breathing smoke. Every Egyptian who cooked inside a mud brick house with no chimney, burning dried dung and agricultural waste in a clay oven in the corner, was breathing the same particulate matter. The World Health Organization estimates indoor biomass burning kills over 3 million people annually in the modern world. The chemistry has not changed. Incomplete combustion of organic fuels in enclosed spaces produces the same carbon monoxide, the same fine particles, the same polycyclic aromatic hydrocarbons, whether the year is 1250 BCE or now. But the priests had it worst. Not once, not occasionally. Daily, for years, in spaces specifically designed to trap what they were breathing. The Ebers. Papyrus contains dozens of remedies for respiratory complaints, coughing, chest tightness, difficulty breathing. The Egyptians noticed the symptoms. They could not see the cause hanging in the air around them. There is a moment in this story that deserves its own silence. Diodorus Siculus, writing in the 1st century BCE, describes the embalmer who makes the first incision in a corpse. The man cuts along the left flank with a sharpened Ethiopian stone, then immediately turns and runs. The crowd chases him, pelting him with rocks, heaping curses on his head, as though by driving him away, they can drive away the pollution of death itself. Stephen Buckley's 2004 analysis in Nature identified the chemicals these workers handled daily: bitumen, coniferous resins, beeswax, natron so caustic it burned skin on contact. They reached into chest cavities and pulled out organs. They pushed hooked instruments through nasal passages to extract brain matter, aerosolizing decomposing biological tissue in enclosed workspaces. The fumes from heated bitumen alone contain polycyclic aromatic hydrocarbons that modern occupational medicine classifies as carcinogenic. The embalmers lived apart, in designated quarters, socially shunned. Their culture understood they were contaminated. It framed contamination as ritual. The reality was chemical and biological, a toxic occupational exposure that no amount of ritual purification could wash away. And still, Egypt's doctors were not fools. The Edwin Smith Papyrus, likely copied around 1600 BCE from an even older text, reads like a modern clinical manual. Case by case, wound by wound, the physician observes, diagnoses, assigns a prognosis, prescribes treatment. For open wounds, the prescription often includes honey. And here the Egyptians were right. Modern clinical research confirms that raw honey has genuine antibacterial properties. Osmotic pressure that dehydrates bacteria, hydrogen peroxide production, acidic pH that hostile microorganisms cannot tolerate. 3,000 years before germ theory, Egyptian physicians were applying an effective antimicrobial agent to open wounds through sheer empirical observation. They noticed it worked. They could not know why. And the same Ebers papyrus that prescribes honey also prescribes lead compounds for eye disease, a genuine treatment and a slow poison in the same sentence, on the same page, in the same medical tradition. This is not a story about ignorance. It is a story about the boundary between what you can observe and what you cannot. The Egyptians saw that coal reduced eye infections. They saw that honey healed wounds. They could not see lead accumulating in bone. They could not see parasite eggs burrowing through intestinal walls. They could not see stone dust settling into bread or carbon particles lodging in lung tissue. They operated with devastating intelligence within a world whose smallest dangers were completely invisible to them. And if that sounds like a failure, consider this. We eat food whose long-term chemical effects we debate in contradictory studies published monthly. We breathe air whose particulate content we measure but do not solve. We apply compounds to our skin whose endocrine disruption profiles are still being catalogued. The difference between us and the woman applying coal to her daughter's eyes is not intelligence. It is instrumentation. We have electron microscopes and mass spectrometers. She had observation, tradition, and love. The tools changed. The problem did not. Think about what survived. The bread is still in the museums, dark and dense and grainy, and under magnification, you can see the quartz particles that ground down every tooth in Egypt. The coal pots are still there, dozens of them, carved alabaster and dark stone, small enough to hold in one hand, and the residue inside them still tests positive for lead. The mummies are still yielding their secrets. Every CT scan a new case file opened on a patient dead for 30 centuries. Every parasitological sample a census of the invisible organisms that shared their bodies. In 1910, Mark Armand Ruffer looked into a kidney older than the Roman Empire and found the eggs of a parasite that is, at this moment, still swimming in the Nile. That same river, that same organism, that same silent, patient transaction between water and flesh, playing out in the bodies of farmers who stand, today, ankle-deep in irrigation channels fed by the same source. If you have found something here that changed the way you see the ancient world, share it. Tell someone the bread was made of stone, and the makeup was a neurotoxin, and the beer was a meal served in an open pot. Tell them the doctors prescribed honey and lead in the same sentence. Tell them the river gave everything and took a piece of everyone who touched it. 3,000 years of daily life. Exposed, documented, legible under a microscope. The Egyptians built monuments to last forever, and their monuments survived. But it is the bread, the coal, the beer, the smoke, and the mud that tell you what it actually cost to be alive in the most successful civilization the ancient world ever produced. The cost was invisible. It was daily, and they paid it with every meal, every sip, every breath, and every careful black line drawn around a child's eye at dawn. We are still paying ours. We just measure it differently. If the ancient world speaks to you like this, carried in evidence rather than myth, there is more to find here. The record is vast. The bodies are still talking. And every answer opens another question that has been waiting in silence for 3,000 years.